My name is Naved Khan. I'm leading the programmatic engineering teams here. Uh, I'm going to assume that most of you over here know about Google and Google Cloud. So I'm going to take some time just to introduce Double Verify for those of you who may not be familiar with what we do and what we are into. So Double Verify is the leading ad verification and measurement platform. And we help brands ensure the effectiveness of their online ads. Now, how do we do that? Is by making sure that their ad dollars do not end up in the hands of organized crime by way of ad fraud, or we ensure that their ads are not displayed on some content which is deemed as inappropriate by them, right? Imagine an airline's ad showing up on a page about a plane crash, right? Like nobody wants that. And we also ensure that the ads are displayed in a place where they can be clearly seen and perform. So we are trusted by several brands, right? By some of the largest brands around the world. We have more than 1,000 customers in almost 110 countries. And you can see some of the largest brands out there. And this list continues to grow. So sometime back, I spoke about how we enable our clients' ad to ensure that they are fraud-free, that they are viewable, and they are displayed in an environment which is brand safe, right? So that sounds like a nice, simple statement, but it comes with a lot of interesting technical challenges, right? So we have to process billions of data points in real time in order to identify subtle patterns of fraud that are consistently changing, right? And we do that by using humans, and that's not the competitor human, actual humans, and AI. We have to classify almost all ad content supported pages into hundreds of categories by using algorithms and machine learning. We have to run privacy safe viewability measurement on almost every device that is connected to the internet. And we have to provide real-time millisecond level latency assessments and predictions in real time for a large volume of requests in pre-bid. Our vision is to make the internet stronger, safer, and more secure. And how we do that is by building independent quality and performance solutions that drive better outcomes for advertisers so that they can pay more to the content providers, which in turn keeps the internet free for all of us, right? Let's talk about some numbers. So as I mentioned, we process more than 100 billion events a day. That's 100 billion ad impressions every single day. We over 500 million devices every single day, and we run over 100 million classifications every day. That's video classifications, image classifications, text, over social, web, and CTV. So we deal with a lot of scale, right? Like not Google scale, right? But for a company our size, it's pretty impressive. And scalability is something that is built into the core of every product that we build. So you can imagine that there is a lot of like cool technical stuff that we can talk about. And we are hoping that we can touch on some of those subjects in future meetups. But for today, we want to focus on some of the data engineering work that we do with Google Cloud and BigQuery. So let's look at the speakers and the agenda for today. All right, so we'll have Michael from Google Cloud team, who will be the first speaker and do a presentation. And I don't want to steal your thunder, Michael, but he opted to do a live demo. Now that's gutsy, right? Every engineer knows how gutsy that is. No pressure. We have good IT team here, for any kind of fire support, so I think we're fine. We have Rodrigo and Meran, then who will be participating in the panel discussions that happen towards the end, the fireside chat that I'll be hosting and I'll be moderating. And from the DB side, we have Henrik, Lynn, and James, who will act both as speakers for the second presentation, as well as participate in the panel discussions. So the agenda, we are breaking it in 3 sessions, right? In the first session, we'll have Michael talking about BigQuery and its latest capabilities, how Lakehouse Architecture is simplifying data management, and the cool live demo. And the second session, we'll have the DB team, and we'll share a real-world use case where we optimize our ad verification logs using BigQuery. And I think we'll share about our challenges, what led us to make those decisions, our key learnings. I think that will be an insightful session. After that, we'll have a 5 minutes break and come back in 5 minutes, please. You can get some snacks and stuff, and then we'll have the fireside chat towards the end. So 45 minutes where I'll ask some questions to the esteemed speakers and subject matter experts and try to focus on some topics where we can deep dive and have some more deeper conversations. All right? So let's get started. Please welcome Michael.
Hi, everyone. My name is Michael. I'm a customer engineer at Google Cloud. Yes, I will do a live demo. They wanted me to do a video. I said, no, we do a live demo, so we'll do the live demo. So today we are here to talk about Lakehouse Architecture. And thank you. That will be easier. But first, let me talk quickly about Google Cloud and the data analytics stack we have inside Google. The best way to do that is to describe an example of pipeline. And the first step, of course, is first you capture the data. You ingest the data at any scale. It could be events coming in, logs, and for that we have a scaling messaging platform for queuing with PubSub. PubSub is first-party service, global scale inside Google Cloud. But now we just announced, I think it was last week, a managed Kafka directly available inside Google Cloud. You also may have some databases, OLTP, and you want to have CDC, data replication service into Google Cloud. And for that, we have DataStream. And then you might have some SaaS application like ServiceNow, Salesforce, and batch data you want to ingest into the platform coming in from S3, for example. And we have 2 services for that. One is data transfer service, which load directly into the data warehouse. And the second one is storage transfer service to move from on-prem, for example, with an agent, directly into the cloud. Then the next step is to build your ETL pipeline. And if you want to process the pipeline at scale, we have a few options for you. Number one, if you're into Hadoop and Spark, we have a managed service named Dataproc. We even have now serverless Dataproc, which can help you build your pipeline. Then we have also Apache Beam with a managed service named Dataflow. And what's amazing about it is unified stream and batch processing together. It vertically scales or horizontally scales. We have a shuffle engine and a streaming engine in the backend we could use. So it's super easy to use. And we announced also a serverless Flink directly inside Google Cloud. And it was announced as, I think, a few days ago. Then you need to store the data inside the platform. And you have 2 options. Option 1, in the lake, inside cloud storage. You can have your structured and unstructured data. Option 2, you can have BigQuery, the enterprise data warehouse, and you can load directly inside BigQuery. And we have active and long-term storage. So we do tiering for you natively. Then you want to use SQL and do your analysis using BigQuery, which is completely serverless. And then you want to do advanced analytics, for example, with machine learning using Vertex AI, or just using SQL in BigQuery using BigQuery ML. You can train, infer your model directly from the data warehouse. Then you want to use, for example, reporting or BI use case. We have Looker, which is multi-cloud, multi-vendor. It works with BigQuery or Snowflake, Databricks, and so on. You can now do connected sheets directly from Looker. And if you want to do data monetization, data sharing, clean room, we have Analytics Hub working with BigQuery to do that. If you are not into code and you prefer a data integration service, we have Data Fusion, which is code-free, just drag and drop, and it will automatically, behind the scene, create your Dataproc, Hadoop, Spark jobs for you. Then you might want to have governance and a unified view of your data. And for that, we have Dataplex. And last, if you want to have some workflow orchestration based on Airflow, we have Composer. We have a fully managed version, and we just announced Composer v3, which is completely serverless. So think about it like a DAG as a service directly inside GCP. So this is a Google Cloud stack we have with the last announcement we made. But let's double click on BigQuery and why BigQuery is so amazing. So we launched BigQuery 13 years ago. It's a serverless, no ops enterprise data warehouse. We built it from the ground up, from bare metal. We are not relying on GCS or GCE to have the workhouse running. You don't have to configure, by the way, any kind of clustering, like a cluster with workers. You don't have to have a VPC. It's just serverless. You just enable an API and you can use it. It runs directly with the backend we have. Like for storage, it works with Colossus. With compute, it's working directly with Borg. And we have the Jupyter for petabit network. So it's extremely fast. And because it's first-party service, we have full control over the infrastructure. So we do our own capacity planning, for example. We don't rely on a cloud provider to have, for example, quota issues or stock out. So basically, we have full control because it's running from directly on Google Cloud infrastructure. And then we have a high throughput, low latency API you can use to ingest data. And when we talk about ingesting data, it could be at any scale. And Twitter, for example, they have almost 1 exabyte of data stored directly inside BigQuery. And last but not least, we have decoupled the storage from compute when we built BigQuery. So we basically bring the compute to the storage every single time we need to execute a query. Now, we are not here to talk about enterprise data warehouse. We're here to talk about a new type of architecture, Lakehouse Architecture. So we need to kind of unify 2 words. One is a data warehouse word for data analysts and data engineers into SQL and structured data with the data lake. And we talk quickly about Dataproc, but it's for data science workload, for data engineers, for real-time analytics. And with data lake, it's great because you can use programming languages and framework like Spark or Beam, but it's 2 silos today. And how do we unify that into a single platform? So let's talk about Lakehouse Architecture. And when I think about it, in terms of what kind of framework do we need to work with a Lakehouse Architecture, I would say we need 3 things. Number 1, we need multiple engine. We need to bring multiple engine to a single copy of the data, a single schema where you can work with your data. It could be using SQL, Spark, Python, vector search, any kind of engine you want. And then we need multi-modal storage. We need to work with all type of data. It needs to be working with structure, unstructured, streaming data. It needs to work with an object storage where everyone can access to the data. And it needs to work with open data format. Databricks open source Delta Lake as an example for open format. We need to support that. We need to support Hoodie as another example. But the market is going into Iceberg, Snowflake, Databricks, BigQuery, and many other vendors invested a lot into Iceberg, which is an open format. Think about it as a high-level management of your data. It brings a lot of benefits, like schema evolution, like hidden partitioning. So it gives you this ability to have open formats and manage the metadata at scale. And then last but not least, you need, of course, the AI foundation. You need to be able to work with foundational model. It could be Gemini, for example, or it could be open source model like Llama. but you need to have this kind of integration. And then you need to consume this workload. And for that, of course, we need a unified layer. We don't want to have silos anymore. So we need to work from notebooks. We need to be able to launch jobs for batch, streaming, and so on. And with BigQuery, we are covering most of the stack. So you might know BigQuery as a point product, but now we have BigQuery as a platform. And basically, we made sure that every single capability we need was integrated into the platform. One example is Spark. Now from BigQuery, you can run a store procedure in Spark directly from BigQuery, like you do with SQL. And I'll show you that in the demo, by the way. I won't go into the details, but just to show you a quick architecture. We launched Managed Lakehouse with BigQuery. We name it Big Lake. It's basically the ability to query Iceberg, Delta, and Hoodie with built-in fine-grained access control directly from BigQuery. We want to have performance acceleration with Iceberg. We want to give you the same experience you have when you are using BigQuery in a native format. We want with Iceberg to have the same kind of performance and metadata. And then we also want to have a fully managed experience. So we launch in preview Big Lake Managed Table on Iceberg, which help us having full support for DML, but also high throughput streaming using Iceberg. And we have now in preview BigQuery Metastore, which is the unified runtime for metadata, which unified SQL and open source engine inside the same catalog. If we double click, we want to query from any kind of engine. It could be an open source engine like Spark, Trino, Flink, BigQuery, whatever you want to use. And the engine of your choice needs to work with the Lakehouse. We have several flavors of the Lakehouse. Number one is a fully managed Lakehouse using BigQuery storage with BigQuery native API, BigQuery native table. But we expose an API, which is a Big Lake API, which lets you work with, for example, Spark, with this high throughput API to work with BigQuery. The second one is the open Lakehouse. So it's on top of GCS, the object store we talk about. And on top of GCS, you have two options. One, fully managed by Google, Big Lake Managed Table, and another one, which is managed by you, basically, and it's a Big Lake Iceberg table. This is an open Lakehouse. But you may also have some data in other clouds, and for that, you could use BigQ Omni as a connection, and then you can do the same thing. You can use Big Lake Iceberg table directly on S3 or Azure. And on the left side, you can see we have BigQuery Metastore for the catalog and Dataplex for the governance at scale. But it's hard. So you want to have simple decision tree to help you understand what option. And we love decision tree at Google. So the first question is which cloud? If it's on GCP, and the next question is, do you care about open formats? If the answer is no, then just use what we have for 13 years, BigQuery native table. You will have a fully managed experience, and it's compatible with open source engine for read API and so on. If you do care about open format and you are into Iceberg or Delta, then the next question is like, do you want Google to manage it for you? Do you want us to do the clustering? Do you want us to do the garbage collection, for example? And if the answer is yes, then you may want to look at the new preview we have, which is Big Lake Managed Table, because it would give you this full DML support, this high throughput streaming, and the fully managed experience from us. We'll take care of the compaction. You won't have to compact the data into Parquet and so on. If the answer is no, then the question is, what type of rights do you need? Because if you don't need high throughput streaming, for example, you might be okay with doing it yourself with Big Lake Iceberg table. It might be cheaper. You can beat Google on compaction, for example. Maybe you will have a better algorithm. But at the end of the day, it's kind of like your choice on which option is the best for where you want to start. So 3 options. And of course, on all of that, you will have unified governance and fine-grained access control. You don't want anybody to access your lake directly like that. Now let's talk about a lakehouse architecture with multi-vendor inside the same architecture. So yes, we can do it with open source. But if you have Snowflake or Databricks, for example, how will that work all together? So the answer is yes and no. Yes, we can have, for example, BigQuery owning a table for read-write, and then having Snowflake reading the table with Iceberg, and same with Databricks. That's what we did with the social team and measurement teams when we did a POC, for example. We tested exactly that kind of use case, reading from one, and another one has read and write. But the issue is when you want multiple write, when you want Databricks and BigQuery or Snowflake owning the same write on the same table, then you have an issue because you need a single catalog for everybody. And I think the market is still maturing. We'll have solutions in the future, but it's still today, you don't have a full read-write compatibility for everyone. By the way, BigQuery do support Delta read. So for example, if a client is on Databricks, most likely they're using Delta format, and we can just read from BigQuery. So we don't have to adopt Iceberg to have this, kind of architecture. So we can do the same with Delta. Now let's talk about a few more capabilities we may want inside the Lakehouse before we go to the demo. So first, we need BQME. Why? Because if you have data in S3 or Azure, it's the only way for you to have a single pane of glass and be able to still, work with this data on other clouds. You may want cross-cloud joins. You may want to join data from two clouds, and that's something you could do if you have BigQuery Omni. You may want materialized views cross-cloud, and that's something you could do if you have a capability like BQ Omni. Then also, we want unstructured data support. We need to be able to work with structured, semi-structured, and unstructured data. So we have Big Lake object table for that, which works with images, audio, documents, videos, and so on. So you can just do your SQL-based pipeline and work with your unstructured data to join what you have unstructured with tabular data easily. And of course, you can leverage Google IP in speech recognition, vision, translation, text, LLM directly from SQL. So the two are super powerful together. So you need this multimedia, multimodal data support inside the Lakehouse. Then you need also this unified experience. You want to give to the users, to the user persona, both SQL and Spark inside the same platform. And that's why in BigQuery, we launched BigQuery Notebooks and also Spark stored procedures to give you Spark routines directly from SQL. So you don't have now to change in the pipeline. We have complex pipeline. You can just have a SQL pipeline and run a Spark procedure inside BigQuery. Behind the scene, we trigger serverless Spark. So it's super simple because you have no infrastructure to manage, no cluster, nothing. Then, of course, we want LLM everywhere. So we added natural language to SQL generation, natural language to Python generation, SQL completion, and we want to have LLM embedded in everything we do inside BigQuery. So that's why we introduce Gemini in BigQuery. Then you want also enterprise readiness, right? You want to have governance at scale. And for that, you need data profiling, you need automatic data quality, you need data lineage, you need to have governance rules directly inside the same platform. So that's why we introduce features from Dataplex inside directly BigQuery as a platform. And last but not least, BigQuery Metastore. It's in private preview today. It's unified SQL and open source engine. And it's something key if we want the architecture to be complete, because it will have all the metadata and be able to work seamlessly between open source engine and BigQuery. You create a table in BigQuery, you want a single schema, and then you want go to Spark with Dataproc, you want to access the same table with the same schema. You don't want to recreate the same definition. You want to access the definition directly from the metastore. Now it's time for the live demo, and hope it works. Okay, thank you. Already switched. Perfect. So when you want to use BigQuery, the first thing you have to do is to go to the Google Cloud Console because it's a first-party service, right? And as I was saying before, now BigQuery is not just a point product like a data warehouse. It's now a platform with like different capabilities. And we have BigQuery Studio where you can go just here and say, oh, I want to work with SQL. No, I want to work with Notebook. I want to work with Spark. So you can decide from BigQuery directly to create, whatever you need. Now we have notebooks directly inside BigQuery. It's using Colab, and I'm pretty sure everyone knows Colab behind the scene, but it's directly integrated inside the BigQuery UI. So the first thing I want to do in this demo is to create a managed table. And for that, we use a taxi demo today. So we want to create 3 tables. The first one is a driver table. We have a schema definition here in the DML. We will cluster per driver ID. And here I specified the Parquet and as a file format, and the table format is Iceberg. This one is a fully managed Big Lake table by us, and I specified the bucket where the table will be created. The next one is a location, table with another definition. And the last one is the taxi trips. So all the trips in New York City inside the table. The next step is to load the data, right? And here you have 2 options. Option 1 is to do batch load into, a Big Lake managed table. And the second option we'll see after is streaming. When we do batch load, we'll just specify the location of the bucket. So I want to load the data from Parquet data from the bucket. One is driver, another one is location, and this one has 45 million records, so a pretty big one. If I show you what it did, it went to, GCS, and it created 2 folders. One is a data folder, which contains all the Parquet file loaded by Big Lake Managed Table. And the second one is a metadata folder, which contains the Iceberg metadata managed again by BigQuery inside the GCS bucket. Next, we want to query the data, right? So the first thing we want to do is just to show you a simple count to see how many counts we have. So the driver table, for example, has 10,000 rows. Remember this number because we'll use it. And the taxi trips has 45 million records. If I just show you the creation of the table, I go inside the data set and I open the taxi trips. You can see here the schema definition of this table. Then the next query, we will just do a simple join, and we'll see the average tip per, ride. They don't tip a lot, I see. And last one is just, a more complex join on the data, just to show you we can join the data on all of this table. Great. Then we want to show you a full CRUD. So a full CRUD, meaning the first thing we want to do is to insert a new row inside the table. And that's something we could do, but we can also add an additional column into the table. So we do schema evolution inside the Iceberg table. So I just added a new column. So here you see the schema. If I click refresh, it will add in a few seconds a new column. Still ongoing. And the last one is we can just see the new driver in the new column. So you see the new column is license plate. If I go back here, yeah, so it's a live demo. Let me reopen it. Why I don't see it? That's interesting. but we can see it here as a new license plate here. And last, we can just delete the row we just created inside the platform. Okay, let's move on now and let's do the streaming use case. So we want to create a new table now. And inside this table, we will create a pub subtopic, which will ingest streaming data directly inside BigQuery. So I just created the subscription just here. If I click on the link, it will open PubSub. PubSub, again, is our first-party messaging service, global service delivery. If I show you the PubSub, it can directly write to BigQuery. It can directly stream the data to BigQuery inside a table named taxi trips streaming. So if I go back here, I refresh, I see the new table, taxi trip streaming, and here it will stream the new data on the fly. So let's do the first one just to show you. I just do a select to show you all the new data coming in. And then we can query the data and show you the new data coming in inside the table. If we look at the number of rows, and I just do it several times, you will see like every second we have new rows coming in inside the platform. So we can do high throughput streaming directly into Big Lake managed table, which is amazing. Let me just delete the PubSub. It will cost me too much money. Yes, perfect. So the last thing I wanted to show you is you can export the metadata. You can force Big Lake to export the metadata, or it will do it on a recurring basis. When you export the metadata, it basically go to the metadata folder and export additional metadata you may need if you want to work with other engine or working with other platform. So let's say we want to work with Spark now, and what we want is to query the same table. Super easy. All you have to do is to have a BigQuery Spark connector in Spark, few lines of code, and we say, I want to work with BigQuery. Here is the same table I used before. I want to count the number of rows, and I look at the total records, and I see 10,000 records. So it sees exactly the same thing from BigQuery. Here, I didn't created a new definition. I don't have a new schema inside Spark. No, it's using BigQuery Metastore to retrieve the schema and be able to query the data. Okay, great. So if we have seen Spark, we have seen BigQuery, but how does it work if I want to use another vendor and work with Iceberg? So let's do it. If we go to Snowflake, for example, and inside Snowflake, we want to create an Iceberg table, the same one we are using inside BigQuery, all we have to do is to have this DML to say, I want to create an Iceberg table. And the metadata, we will point the metadata to the metadata I showed you before inside the lake. And I will just click create, and it will create the definition inside Snowflake. Then I can just do a simple select, and you see again 10,000 rows. And just to show you I didn't cheat, I go to Iceberg, and here we have the new table. So here is the table definition, 10,000 rows. You can see the same column we had, including the license plate. And you can see the data we have ingested together inside BigQuery, but directly from Snowflake. Again, this is read-only. If I'm doing some, insert from Snowflake, then it won't work inside BigQuery because it doesn't have the same metadata. But you have seen here a full demo of using BigQuery, using Spark, and using another vendor like Snowflake. And that's exactly, by the way, the POC we did with Double Verify when we tested that. Can we switch back to the presentation? So I have just one more slide just to recap. But basically today, we have seen three things, if you have to remember. One, we have seen a fully managed streaming optimized Lakehouse. We do support batch and streaming ingestion inside Iceberg table. We can work with Delta, we can work with Hudi, you can work with open source engine like Spark, you can work with BigQuery. And we have high throughput streaming with big lake managed table. When you work with Iceberg, the amazing thing when you have a fully managed Iceberg is we can manage everything for you. So storage management, clustering, adaptive file sizing, garbage collection, all of that can be handled by us. This way you don't have to handle, for example, the compaction. And that's something which helps clients to do it and be much faster. And the last one, which is key, is interoperability, security, and performance. You can query from BigQuery, from open source engine, and we want to give you fine-grained access control enforced across engine. You don't want to have you don't want to open up your data and anybody can use any engine and then you have no security on it. And last but not least, performance acceleration is key. You really want to have acceleration on the metadata. You want to have the same experience you have on the enterprise data warehouse, but inside the Lakehouse directly.